Welcome to Careless Coder. Today we will investigate this weird thing. What? Motherfucker! So a couple of days ago I asked on YouTube whether you guys were interested in some hacker scene stories of the late 80s, early 90s here in the Netherlands. And 100% resounding yes, which amazed me because this knowledge that I'm going to share with you and the stories is very much archaic. Even Indiana Jones would find it old-fashioned, and that is saying something. Now, the cornerstone of the Dutch hacking scene is, without a doubt, Access for All, which was an internet startup, and these guys that started it up were also some of the editors of this little underground magazine called Hacktick. And I will show you the Hacktick on screen because they archived them. I also downloaded them on my repository, link below, just in case they take the website down in the future because they don't care anymore. This is knowledge that needs to be archived. The great thing about the Hacktick was that it was really amateurish. It was really just a bunch of A4 sheets, photocopied, folded with a couple of staples in it. And you could have a subscription, prepay for, I believe, 10 issues for 30 guilders, and individual issues that some very good bookstores, with allegedly the Secret Service in front of the door looking who bought them, for 4 guilders. I will read you a passage that cracked me up going through them again, that I translated in English about this very same thing. So let's jump in and first read that. So this is the Hacktick, or at least the archived versions of the Hacktick. And if you can see, it's just a photocopied magazine. There was a stack of A4 papers folded, so basically A5. And, you know, the typical 80s layout. And this is a treasure trove of hacking knowledge back then. And they were kind of prolific as well. Ooh, we had a color page even. Colored paper. They were prolific in a sense that I want to read you a translated article about ordering the Hacktick. And yes, I know the majority of you do not have the ability to read Dutch. AI from Google is actually very good at taking these images, doing an OCR on them, and then taking that output and translating it to English. Like I did with this one. And let me read this prophetic piece of Hacktic history. Privacy. It is true, if they want to, they only need to look at our bank statements to see who is subscribed. We consider Hacktic to be an utterly harmless little magazine, but there is a chance that local, regional, national, and in the future possibly even European authorities, how prolific, they are the worst, fuck the EU, may disagree. If you have a position in society that you don't want to lose, you can also enclose cash or a check and your address in an envelope and send it to our PO box. Then we'll know enough. Your Hacktick will always be sent in a neutral envelope. Your landlady might think you're buying porn by mail order. Hacktick is also available at good bookstores, perhaps recognizable by the surveillance team out front. Disclaimer. Information in Hacktick serves only an educational purpose. Use of the information could be illegal or a threat to national security or just being naughty. The editors disclaim all responsibility for the use of readers of the information contained in Hacktick. Okay, so for educational purposes only. Now I have to say that I only read this, maybe I didn't have that issue last night. So we may or may not have allegedly used or abused some of the information in the Hacktick. Like for example, spoofing ATF-1 Carphone's to dial naughty numbers for free. I cannot confirm or deny that we did that. What was that? That's my legal advisor. I do not need to nod my head. Oh, not my head. Okay, here we go again. I cannot confirm or deny that we did that. Oh, I did it again. I cannot confirm or deny that we did that. That's hard. Yeah, that's good? Okay. Yeah, so ATF1 spoofing was one of those things that we got from this magazine. And we may or may not have used or abused. I cannot confirm or deny that. So let's read the article that I translated, and then we'll have a look at the code, which I rewrote because I couldn't find it anymore. How we actually send this on how we allegedly send this on a homemade transmitter back in the day. Cannot confirm or deny. So I won't read the whole article, just the beginning, so that you get a sense of what ATF1 was. ATF1 basically was Auto Telephone Network version 1. Carphone version 1. So the first car telephone system. Calling from the car, necessity for some, a status symbol for many more. For a few, a brilliant way to extract money from willing to pay yuppies. And for a select group, the perfect hack. I cannot confirm nor deny. Telecommunication in the Netherlands involves more than just making calls at home. There are currently 3 systems in use, known as car telephone 1, 2 and 3. Very, very, very interesting names. Network 1 uses frequencies in the regular mobile radio band and can therefore be received with a scanner. And also with a little homemade simple 2-transistor transmitter and a amplifier actually sent upon. Cannot confirm nor deny. So it goes into the frequencies of the different bands. This article deals solely with car telephone 1, or ATF1 for short. The developers of this first telephone network weren't exactly sticklers for security. There's not a single code or safeguard in the protocol. The whole thing leaks like a sieve. ATF is full duplex system, meaning you can talk and listen at the same time. This means each call uses 2 frequencies. Yeah, that was a bit of a thing, except that we found out that in our case that we were allegedly just listening to naughty stories. We could keep the transmitter on the car frequency and listen on a scanner that we allegedly recorded with. So full duplex means 2 frequencies. One frequency is called the base channel. The repeater for the car telephone network transmits on this. These repeaters are set up all over the country and are directly connected to the BTD, Special Telephony Services, also known as 06 Central in Rotterdam. That was how we called it. The other frequencies in the mobile channel, the vehicle transmits on this one, and is not always a car. Inland skippers use ATF1 heavily. Yes, we of course have the Rhine skippers. They were the first actually to adopt the car telephone. So it should technically be a ship telephone or a semaphone. Okay. See table 1, if blah blah, not interesting. Let us go to what we did from car to landline. This is the hack that we allegedly did, which I cannot deny or confirm. The Carphone searches for a free channel. So I omitted the frequency tables because they are completely useless these days. So we listened for a frequency that just sent out the frequency beacon, meaning that it is available. If you hear voice on it, you know it wasn't available. So the car telephone searches for a free channel. We did that by hand, allegedly. On this channel, the central constantly sends the same telegram. That is the channel. It consists of a double digit. The first is always a 9. The second is the region number, not the channel number. And for example, Amsterdam is region 5. So this is what a chirp on an empty channel look like. Or you could just hear it and you know, I can actually clear it by sending a 600 millisecond 2070 hertz beep, and then actually send a start, the Carphone number, and the landline number without the leading 0. Now you can see that actually Carphones were very limited back then. This is indeed a 5-space thing, and well, the Dutch network with around 3000 was already pretty much full. So you were lucky to make a phone call at a certain point in the early 90s. And yeah, these days this number is now a 10-digit number. Every phone number in the Netherlands is now 10 digits. So this uses a frequency shift keying, which basically means the ZX Spectrum users know that very much. That sound, yeah. That is frequency shift keying. A 1 is a certain frequency, a 0 is another frequency. Now usually these frequencies are a multiple of 2, which makes it easy. That way you have a divider. So the next one is half of the root frequency. This one you can see, it's kind of a weird little distance. But nothing the Commodore 64 cannot generate close enough for it to work. Now each beep lasts 10 milliseconds. So after that 600 millisecond 2070 hertz beep, we had a 0, so that's a 2070 hertz beep that lasted 10 milliseconds. Then a couple of ones that took then 30 milliseconds at 950, etc. And that is basically how the hack was done. Now, funny enough, this contained something that showed how bad this network was. International calls via ATF1 from the Netherlands are no longer possible. Rightly so, just like they omitted the 06 numbers, the naughty lines, a couple of months after we started it. That's because allegedly started it. That's because a whole bunch of clever guys were selling stolen or grey imported Carphones where you could set your own number. So if you knew your neighbor's number, you just put it in, because the 06 Central would actually check if the Carphone was registered in order to bill. If it was a non-existing number, you couldn't make a connection. So you could just use the phone number of that Yuppie that you hated with the beamer that always cuts you off. So so you could basically program an EEPROM or just program it by jumper wires. Very, very dodgy, right? If you live close enough to the German border, I'm not sure if you're happy about that, but if you were close enough to live next to the German border, you can still call anywhere in the world for free using the German repeaters, because Germany didn't close down. At least not that part. East Germany was pretty much closed down, of course. So yeah, that is basically what we did. And here also you can, the call doesn't have to be full duplex. You can be off air for up to 10 seconds before the central ends the call. Like I said, if we were allegedly calling the naughty numbers, we would just keep the transmitter on this frequency, occupying the band, not saying anything, just sending in the carrier wave, and we could listen on our little scanner and allegedly then record that to tape. So let's jump into the code and see how we actually allegedly implemented it. I think this code may be better than what I allegedly, I cannot confirm nor deny, wrote 3530. Now obviously there's no guarantee that this works because, well, ATF1 doesn't exist anymore. But yeah, I'm pretty sure that at least the basic implementation works or not the basic, the assembly, but the basic implementation of this is fine. It should actually work, but maybe there is a typo here and there in this little table, etc. You know, that's why you usually debug in a real system that we don't have anymore. But yeah, frequency shift keying is something that you find a lot in telecommunications. Basically, having different frequencies for a 0 and a 1. And the Commodore 64 in these audible frequencies was perfect for it, especially with this 10 millisecond time. I mean, that is, even for a Commodore 64, that's a lot of time that you can just waste doing nothing. So what we did, or what I did, and like I said, this is code that I created from scratch again, but it was similar back in the 80s. I would set up a CIA timer that triggers every 10 milliseconds. So that is what I do here. Well, reset the variables to 0, set up the SID so that we can generate a square wave, and call the 270 Hertz tone. So I set the SID to 270 Hertz. So it is beeping now. We set up that whole the timer, and I just basically wait until this flag is set to 1, and that is done all in the dial IRQ. So here, every time the IRQ triggers every 10 milliseconds, I increment the counter. And we saw that also in one of the tutorials that we did on raster times, that we could actually just increment a counter and actually spin lock on that counter. Then we could do other things as well. You don't want to do a lot of work inside the IRQ, especially if you potentially roll over. Then you have an IRQ swarm and there's no recovering from it. So this is a very safe implementation. And with these frequencies, it's easy enough to just have a spin lock waiting on it. So yeah, after 10 milliseconds, and of course we reached 600 milliseconds, I set a 1 to that variable, and I set the IRQ counter to FF, so it rolls over to 0, just the next one, just convenience. And we accept the IRQ. So that is all what the timer does. It just increments this variable, and if 600 milliseconds is reached, it sets this to 1. Right, and you need to call the other interrupt vectors, because we still have basic running, for the reason that I could use basic to override right here on top. Usually I put my variables on the bottom, but this one is on the top. So I could override in basic this dial string. That would be easier, but we always used, at least I recall, the old KCS cartridge monitor. Just went to 1000 hex and just overrid it. Because we are hackers. We don't deal with user interfaces, convenience. Like, come on. Right, so we have this set up. And then basically we do the process dial. We load in the number that we're dialing. So the S in this case is the first one. Number. Right, where were we? Right, so we load in that number in A. We check to see whether it's a digit. So that is what this does. If it is a digit, we jump here. I add 6 to it because we multiply it by 2 and add 6 to it because every telegram is 2 bytes, right? And sometimes they use 1 byte and a second byte if you generate channel numbers. We didn't need to, but at least this code allows you to do that if you so inclined. Right, so it parses basically this string to one of these bytes, star telegram, so it will send these 2 bytes, and a 1 it will send these 2 bytes. Now the send bytes is actually done here. So we increment the offset table because the next one is the next byte that we need to read. I could do that over here, but I like to spread timing because, well, this is potentially timing critically, even though 10 milliseconds, even for a 1 megahertz Commodore, is an eternity. But yeah, I split that just to be a little bit more efficient. And then I call send bits. Now what I do here, this is where the real magic happens. And it's a macro. The reason why I do a macro again is just for performance sake. I realized that we never did a macro with kick ass before in the tutorials. But yeah, it's just .macro. Function name, you could put a variable in here that you can use, and brackets. And what it basically does is just takes this code and injects it here. This way I don't need to have a subroutine because a subroutine takes about 8 cycles. So here I load in 8 because we have 8 positions that we need to shift through. And I roll each bit out of into the accumulator. If the carry is clear, then that is a 0 in the accumulator. Then we sound the 270 Hertz. If it's set, it's 1, then we sound this, and then we jump here to the 10 millisecond wait. And basically what we're just doing is we see what the IRQ counter is, and we compare until it is changed by the interrupt routine. Because every 10 milliseconds this is incremented, so it's no longer the same. If so, we decrement Y, and if it's not a 0, then we keep sending those bits. And that's basically how we do it. Right? So this modulates each bit in a 0 or a 1, a 1950 or 2070 Hertz beep. And you see this a lot in communication stuff. Now here we have the macros to actually set those frequencies. 0, then we turn it off. This is calculated to be around 2070 and this by 1950. There's a nice formula in the programmer manual for that. And that is it. So then you get this. So as you saw, we sent the string twice. That is confirming the ATF1 specifications also, even though the Hacktick says sending it once is enough. When we tried it allegedly, we found that our success rate by sending it twice went up from about 55% to 85%. Because frequencies with frequency shift keying, especially over the audio channel, are really finicky. If the signal is too low, it isn't really gathered. If it's too high, it causes distortion and it's not really gathered. So yeah, it was a bit finicky, but 85% was allegedly our success rate, which was really, really cool. And even Carphones in the 80s themselves had about a 90% success rate in getting a call through. That's how buggy those initial systems are. We are spoiled with today's GPS and G5 stuff, 5G stuff. It's exceptional what we have these days. So what we allegedly did was actually take the audio from the television, and now we have this lovely beast, so you could use the actual 3.5 millimeter jack, Gideon's beautiful Ultimate 64 Elite 2. But we took it from the television. That also adds a bit of hum and noise, hence that flaky 85% success rate, allegedly. And we put it in a homemade transmitter. Basically just 2 transistors. One that is on that 158 something frequency with a little trim pot, so we could find a free one, allegedly. The audio goes in, and then where usually antenna goes, we allegedly put it into a 10 watt power stage. And that allegedly worked really, really well. So yeah, that was cool. But then we wanted to go portable. And when going portable, it was of course the POJO time. The battery is dead. Yeah, so this brought in a challenge because this has no audio and the PC speaker is nowhere near good enough to do that. So what I ended up, or together with my electronics friend, is created a parallel interface where we just had an Ne555 timer that is set to the low frequency, 1905 as a base frequency. And then we have one little transistor, and that would actually put another potentiometer in parallel, raising that frequency. So going to the 2070 hertz. Works really amazing. It's basically like this, but in a very small interface. And we could fit that in a backpack together with the little transmitter that doesn't really take that much power, except for the power stage that allegedly needed to be plugged in because big batteries were a bit of a hassle. So what we allegedly did, put everything in the backpack, put it in the corner right next to a socket, and put that socket in there, and it was just laying there, and we would stand in the hallway looking into the offices, and those offices were just glass. We call them aquariums because you saw all these office ladies. And the POJO was programmed to randomly call the administration number between 1 and 5 minutes. So the phone rings, they answer, and there is no signal because we didn't really send anything. And they throw the horn on the receiver, so basically a telephone ding-dong ditch. I know, very immature for a couple of 17-year-olds. I totally agree. Allegedly, if it happened, right? Allegedly. So, after the third or fourth attempt, another student allegedly came in and was actually using the payphone. The phone rings, she picks up and she sees the guy and she thinks it's that student that is ditching the call all the time. So she goes to him, grabs him, and he truly doesn't know what happened because he was, in all intents and purposes, making a real phone call. So that was a really nice giggling situation for us, allegedly. Yeah. The last time that we allegedly tried this was about in '91, and then there were better solutions if you wanted to hack phone systems, more reliable, and at least you're not charging some random yuppie a shitload of money, because car phones, the calls were really expensive, like easily up to $2.50 a minute. And then you also had your I believe it was $5 a minute for the naughty line, up to 50-minute naughty naughty story. So yeah, and we did that allegedly 4 times for a cassette that we then would actually sell, duplicate and sell. And allegedly that was a very good business. Yeah. Yeah, the good old 80s, man. I miss these days. And I miss these sorts of sounds. Those are the sounds that we grew up on. Whether it's this or your modem, yeah, your ZX Spectrum, also frequency shift keying. Good stuff. Good stuff. And it's really good to know electronics when you're a hacker, but also a software engineer. So I hope you learned something, and see you in the next one.